Do what? Well, I bought it from somebody. I had bought it from a couple students, and I had two of the students I've already brought, but I had bought from a third student. I don't remember who the third student was, so I was like, "Do I get my cookie dough?" So,
what?
It's not
cookie dough. He wants it.
Yeah, I can't remember who I had bought the third one from. So I go home yesterday and I have 2 cookie doughs, and I know there's a third one that I purchased, and of course, so ladies.
Whoever's married cookie dough.
If you get married, when you get married,
who's selling cookies?
So I'm just gonna tell you this, ladies. When you get married, don't hold it against your husband if he brings home 2 things of cookie dough right after Halloween. You know? Yeah, I had to go hide it because they all wanted to eat it. Like my wife and kids were like, I'm looking at my kids and they have 45 pounds of candy, chocolate all over their face, and they're freaking freshmen and junior in high school. I'm like, geez, act like you're in high school. Go barf on each other. So, no, I just couldn't remember who I bought from, so I apologize. What'd I do? I do. I live by Arapahoe High School.
You live kind of. Do you live by South Glen?
I live by Arapahoe.
I do live close to South Glen. So I live one neighborhood south of South Glen. Do you know where Powell Middle School's at?
Yeah, that little lake in there.
Maybe.
There's by South.
I don't know what lake.
It says Sunfish Lake.
Oh, okay. Now, if you know where Powell Middle School is, if you find the tennis courts at Powell Middle School, you will find my house. If you are that bad kid that hangs out at my neighbor's house across the street, shame on you. You shouldn't, because we have the quote-unquote cool neighbor across the street.
I have a funny story about Powell.
Uh-oh.
Can we hear it? Please let him tell it.
No, we'll hear it later. All right, let's take a look at 6A. Was there any questions that you came across on 6A? Any questions at all?
Just do the whole thing.
Yeah, I don't really understand it, but I did. I just need to find it.
It's not really the whole thing we're looking to do. It should be real easy to review. I was looking to hopefully do less than... Go ahead.
What about 1?
Which one?
12.
12. Number 12. We have 6x raised to the 0 power times 6 to the 3rd times 6 to the negative 4. Okay. So what is 6 raised to the 0? 1. Cool. And then 6 to the 3rd is, let's just keep that as 6 to the 3rd for right now. And then I think that was a negative exponent here. So that wants to move down. So now it's going to be this. Is that all right so far? Tug of war, who wins, top or bottom? Bottom by how many? What's what? 6 to the 4th. Because that was a negative exponent and wanted to move down. So I get 1 over 6 to the 1st, which is just 1 over 6.
See, I plugged 6 to the 3rd in.
So the calculator got 216?
Yeah, I got something like that.
Yeah.
So that doesn't work though.
It could if you follow the rules of tug of war. So what happens with exponents a lot of times is you get to a value that's too large for your calculator. And then we actually create something called logarithms, which we'll learn next semester. It's exciting stuff. It's how you read earthquakes. Yeah. 11? Yeah. Number 11. 6 to the 2nd. And then 6 to the negative 2. And then 5 to the 1st. And then that whole thing's raised to the negative 2. Okay. There's all kinds of ways we could start this problem. I probably would do this. I would multiply this here and here. So then I get 6 to the 2nd. And that gives me negative times negative is positive. And then negative times positive is negative. Is that okay so far? Not quite done with this yet. The 5 to the negative 2 wants to move up. So 5 to the 2nd is 25. That's going to be on top. Tug of war with the 6's. Who wins, top or bottom? Bottom by how many? 2, and 6 squared is 36, so that's done. Did I answer your question? Anything else? We're good? Happy?
Yep.
Not really.
Not quite, but that's
Okay. If you would, make sure your name is on that and anything else you might be passing forward. And a gentle reminder, those of you who needed a little bit more time on the test or need to take the quiz, or need to take the quiz, you can today and tomorrow, whatever your off periods are, just come find me. My schedule's on the door. If you come in 4th period today, I have Creek 101, so you had to come across the hall to Creek 101, but my schedule's on my office door right next door. I will not be here after school today, but I will be here after school tomorrow if you need it. Okay? I will tell you, so far I have graded 3 quizzes because those students had come in. Grades were percentage-wise 97%, 95%, 87%.
I don't believe it.
For last test? For this, the quiz?
Well, I've graded 3 so far because 3 people have gotten them done.
What's the due date?
How do what?
Yeah.
So,
I'm so sorry.
So, and those who did that, those good of scores, they are not as smart as you guys.
Oh, okay.
They're all from 8th period, like Tomer back there.
That's good, Tom.
So yeah, so 3 people from 8th period have theirs done. They came in this morning, got it done.
What about a kid who came in yesterday?
Oh yeah, what'd you get?
Probably not good.
Oh, I didn't grade yours yet.
Probably not good.
Hang on.
Like 60%.
He knows.
No, I gotta find yours. I forgot you came in yesterday. Thank you, Sam. Yours is right here. I will grade yours next period. I'm so sorry.
Don't worry.
Hey, you got numbers for answers. That's good.
Yeah.
There's people who have pictures for answers, so you're good. You got numbers.
He doesn't have any degrees.
I need a stretch.
Sorry about that, Sam. I meant to take care of you.
I'm just surprised.
It's all good.
Shut up.
Definitely
Shut
did
up.
get 87 though.
Shut up. Shut up. Now.
But I'll probably do better. It's all good.
I'm dopey. He'll be goofy, easy. Okay, so he turned in.
I don't know.
Yeah, we give you 5%.
I give Audrey
Liam, I think I counted enough, but you know me. I didn't count enough. All right, so
Stop, I found it.
don't be lying.
Yeah, don't be lying.
Don't be lying.
Who?
All right, so ladies and gentlemen, I just run over the restroom.
They're so
All right, so this chapter 6, it's on polynomials. Now, I know I told y'all that there is something called quote-unquote capstone test, and Algebra 2 is one of the capstones. There's 9 or 10 capstones for you to achieve. If you can get past this capstone right now, this goes really, I'm just saying this to the sophomores, but everybody is going to take these. If you get past these capstones, there's 3 capstone tests in CP Algebra 1. And you can actually take it as many times as you want during this school year. But at the end of this chapter, we will give it to you. It's on the computer, and it's on polynomials. Now, what?
At the end of 6?
At the end of 6.
Oh, perfect.
Okay? Waiting.
But will that be our test for 6?
Well, no, I have my PLC tomorrow for Algebra 2, and I gave you too many now. Shoot. I have the PLC tomorrow, so we need to find out. Now, there's a lot of schools in the district that have done this. They changed all their curriculum so they can make sure these tests are taking place right away. And then they're coming back and they're saying, "Our kids aren't doing well." It's like, Well, no, because there's a progression of math of how you teach it to give the ideal time. I think we are actually given the polynomial test. There's the polynomial test, there's the one on logarithms, and then there's the one on exponentials. Don't worry, we'll get there later. So, this chapter 6, so things I'm going to propose to my PLC about this capstone is you need, on this first capstone, you need to get a 7, 8, 9, or a 10. Okay, 7, 8, 9, 10.
This test,
We don't gotta take that.
doesn't apply to us.
Well, the sophomores does. But the juniors, you're off the hook. But everyone's going to have to take it. So one thing I'm going to try and propose.
Why do you say that? Everyone's gonna take it, but
But it doesn't apply to the
what does that mean?
Because the class of 2021 has to pass a certain
That's
math.
stupid.
Class of 2020.
Can I be
No,
like
no,
exempt from
no.
it then if it doesn't affect me?
No, but I'm going to have everybody take it.
No!
Yeah.
It doesn't count for you for anything, so why are you worried?
But I'm not going to have half my class take the test and the other half sitting there getting donuts, unless you're getting me donuts. So.
Can we get you donuts?
No.
Why?
So-
We're the ones that can leave.
No, you can't.
Just don't talk about class.
Miss Hannah, who has her mom call her out of class.
I'm sorry. Mom makes me sick. I threw up last night.
We
Whatever.
whatever.
Her mouth, that doesn't count.
I know. If you burp, that's called acid reflux.
No.
Take a couple Tums.
No, it's something else.
Just
It's scary though.
Yeah.
It's that time of the month. Throw up.
It makes me throw up. It happens every time.
It's a
so
serious
bad.
problem.
I cramp.
I'm
Women
recording
have to deal with it every single month.
right now.
It's not her fault.
I was so nauseous.
11 minutes in.
It's Mother Nature. Don't you want Hannah to have kids?
Just have you know it. 11 minutes into the lecture on the video, we've talked about anatomy. All right, but so anyhow, we're going to talk about polynomials. Do me this favor on polynomials. Do me this favor on polynomials. Would you sit? You've gotten up 7 times already.
This is the first one being all day.
Making up for lost
Do you know
time.
how much it makes my mouth dry? I need water. I'll be really speedy.
I think there's some cranberry juice.
Yeah,
you
there's
can
some
drink.
cranberry.
You're gonna lick the carpet right there.
So gross. Why would you say that?
I didn't sleep like
All right, that's just funny. I love that stuff.
That was funny.
I do. I agree. I'll
It
remember
was
you.
hilarious.
So I'll remember you for the rest of my life.
I'll remember you.
Yeah, baby. All right. All right. So,
Picture's awesome.
hello. This is me up here, trying to kind of lead you. So do me this favor during polynomials. If there are things that on polynomials that you got stuck on, you have to ask me. Let's get it down. My goal is for you is I want every student to pass this polynomial capstone first time.
Oh no.
Okay, you will.
Yes, you will.
So do me a favor,
When are we taking?
and you can sit there, sit down. Okay. This, see my arms? This is what a polynomial does. That's just normal. If I have a negative as my lead coefficient, it does this. If I'm raised to an exponent that's even and the coefficient on it is positive, this. If it's even and it's negative out in front, it's this. So your polynomial dance is this. Okay? I expect to see y'all dancing that way down the hall here.
This,
And then you got the kid who's taking a trick going, dude, check it out. I can do the wave, sine function. All right. All right, so there's a lot of information that comes on polynomials. Now, guys and girls, I know. So the nice thing is if you don't have any of that on your paper, which I know you don't, that's great. I don't think you need to go and copy it all down. The important information here, we'll overwrite on top of this. The important information for you is a polynomial function is something like 3x to the 10th power plus, okay, it doesn't have to be the 10th, but you have a descending order of exponents. Sometimes you have a gap in your exponents, but we'll talk about that. The degree of the polynomial is the highest exponent. So if you take a look at a polynomial, so let me just put something up there. This is just an example. Let's say we had 4x to the second plus 7x to the 10th minus 3x to the 5th. Okay? What you have to do is you have to use a little bit of Sesame Street skills. Which exponent's the biggest exponent? Which exponent's the biggest? Is it the 2, the 10, or the 5?
The 10.
The 10. So guess what? The degree of this polynomial would be a 10th degree polynomial.
Wow.
Not too bad? Guess what? That's one of the questions on the capstone. Can you do it? Okay.
Wait, when is
Might have-
this? When is the capstone?
Thanks for listening. It'll be at the end of this unit.
Okay, well,
But when's
like,
the
is that
what's the
So that-
date kind of thing? Like, is that in
at the end of the unit?
December?
Just let it be.
So we
December, November?
Yeah, aren't you a junior?
in December. Don't worry. The day of the capstone, I'm sure that you'll get a note to get called out of class.
Oh my god! It wasn't
In the middle of
vomit.
It was her vomit.
It was
You
her
know what's
vomit.
going on, Stir. You teach the
It only
anatomy
counts if you
class.
vomit on
I don't know. I
You
don't.
teach the medical chemistry.
I
I was
don't.
uncomfortable.
You had
I was
scars.
vomit.
You had
Vomit
scars.
on my pants for like an hour. I
You did that to yourself. You
wouldn't let me go
All right.
home.
That was your fault.
Okay. Hush.
I blame it on Clay.
Hush. Hush. So we just talked about the highest degree. The degree of the polynomial is the highest exponent. Everyone's set with that. We love you though. All right. Leading coefficient. Leading coefficient. Leading coefficient. So if I have a polynomial that looks like this. Now, are you going to have a problem this long? Yes, I'm sure. So first thing. What's the highest exponent? So it's a fifth degree polynomial. My leading coefficient is whatever the number is at the base of the highest exponent. So what is my leading coefficient? 3. Anyone stuck on that?
No.
Yay.
Why are we
And then, so then the constant term is the only number that doesn't have a letter attached to it. So what's the only number that doesn't have a letter attached to it? 2. So that's our constant term.
Wow.
Everyone with me still so far?
Yes, sir.
Yay! Can I move on?
Yes.
Again, it's up to you if you wanted to write all this information down because I know it's not on your papers, but honestly, I don't think you really do. All right. So, standard form of a polynomial is just taking the polynomial and changing the order from the highest exponent going to the lowest exponent as you read left to right.
That makes sense.
So, this is in standard form because it's 4, then 2, then none. So that's your constant -5, right? Your lead coefficient is 3. This is a 4th degree polynomial. Agree?
Mm-hmm.
This is not in standard form because this should be x to the 5th here minus 4x to the 3rd minus 5x. Okay? What degree is this polynomial now? 5th. What's my lead coefficient? 1. Do I have a constant term up here?
No.
No, sir.
So it's 0. 0 is my constant. Okay? Everyone okay so far?
Yes, sir.
So highest exponent is the degree. Lead coefficient is the base number with the highest degree. Standard form means I need to rearrange the order and put it in descending order going from left to right. Anyone stuck?
No, sir.
No.
Yay.
No, that's it.
All right, so degree. You have a 0 degree. That's a constant. Okay? I don't know if you know what a constant looks like when you graph it, but if you had y equals 3, it's a horizontal line at 3. If you have y equals -6, it's a horizontal line at -6. Okay? Vertical is x equals. Y equals is what we're going with. Okay? We're dealing with function. We're dealing with functions. That's not a function. Vertical is never a function. Right, good. All right, first degree is linear. You've dealt with linear equations for a long time. Yes? Okay, they form straight lines. Yay. Quadratic we just got done with. Quadratic we got done with. It either opens up or opens down depending upon the lead. Okay? Cubic. Cubic's the one that looks like this. So let's see if you can figure this out. Ready? Okay, third degree is called cubic. 5th degree. Okay, I'm going to show you what the graph looks like on all these. Okay, these are the end behavior. My hands are the end behavior. Still with me?
Yeah.
Okay, cubic,
Cubic.
Fifth,
Fifth.
seventh,
Seventh.
ninth.
Oh, so it's odds.
Yeah, everything that's raised to an odd looks like this. Unless,
It's one.
unless,
It's one.
shh, hang on. Unless my lead coefficient's negative, then watch. If my lead coefficient's negative, boom.
Boom!
Got it?
Yeah.
Okay, actually, I had to go this way. This is what, boom. Yeah, you're going to get there. All right. The quartic, fourth degree. So if it's squared, if it's to the fourth, sixth, eighth, that's what my end behavior. If my lead coefficient's negative, down. Okay? We're going to do that enough. Don't worry. You'll learn the polynomial dance. We'll bust out some music. We'll get a disco ball, laser light, smoke machine. It'll be awesome. All right. All right, so item 1, decide if it's a polynomial. Okay, first thing. Rewrite it in standard form.
That's a polynomial.
Thanks for listening. And state the degree and leading coefficient. So, is this a polynomial?
Yeah.
Is it in standard form as it sits?
No.
No. So,
Negative 2x to the 4th.
good.
Plus 3x squared.
Good.
Minus 9x.
Good.
Minus 7.
All right, so what degree polynomial is this?
4.
Fourth. It's a fourth degree polynomial. Still with me?
Yeah.
Sir, yes, sir.
What's my lead coefficient?
Negative 2.
Negative 2. What's my constant?
7. Negative 7.
Negative 7. This graph and behavior, this is what it looks like. Why is it both going down? Negative. Why are the ends doing the exact same thing?
Because it's
quadratic.
What's even?
It's a quadratic.
The exponent.
The exponent is
4.
4, which is that what kind of number?
Even.
Even. Okay?
Odd.
Good so far?
I'm really on.
So this looks like this if I graph it, okay?
Whoa.
Wait,
Okay.
I need to.
Yes.
Good. All right. Hey, taking a look at this next one here. Is this written in standard form?
No.
Well, is it a polynomial? What do you think?
Yes.
It looks like it.
It's not correct.
There's one thing up there that makes it not, and it's not the 5/8.
Negative 2x to the 4th needs to be on the bottom.
Yeah, if you have a denominator that has an x in it, a denominator that has a variable, still with me? Not a polynomial.
Oh.
Now, you could indeed graph it, but it's not a polynomial.
Wait, why?
Because that actually is the same thing as saying this.
Oh. Okay.
Okay? And if you have an exponent, or if you have a variable in the denominator, the polynomial's out. So this is not a polynomial. Okay, what does the graph look like? I don't know. I don't care. We're not dealing with it. All right. Tell me you're talking too much.
Come on, guys.
All right. Number 3. 1/8 x to the 3rd. Seems good so far?
Yes.
I have the square root of 3, but
Wait.
x to the 4th is outside.
You have to go back and on this thing.
Good.
You can watch this.
So this is yes.
Yes. Yes.
I need to make it in standard form. Notice that is not under the radical, so it makes it a polynomial. Okay? So this is indeed a polynomial. Guys and girls,
Yes.
the end behavior of this polynomial looks like this. Why?
Negative. Because it's negative and coefficient.
You have a negative out front, so your negative coefficient, and then
it's a positive even.
so because you have an even highest exponent, that means your end behavior is going to be the same. Okay. Number 4, is it a polynomial? Sure is.
Yeah,
Let's
buddy.
put it in descending order.
Yeah, buddy. You gotta say yes. Yeah, buddy.
All right. So, end behavior on this. This looks like this. Got it? This looks like this. Why does it look like this? Because remember when we were talking about
Even
the
and
plus
odd.
minus plus
Yeah.
on the sign line?
I do
You always
know.
start on the right. if this is positive over here, if this lead coefficient, no matter what that number is, as long as it is a positive number, our end behavior is going to be on positive. Okay? Now, if this is a negative, that changes things. Okay? As you would have seen on this one, this would have done this because we have a lead coefficient that's negative. So the end behavior here, as I go to infinity in the x, my end behavior, my range goes to negative infinity. On this one, as I go this way, coming this way, to positive infinity in the x direction, my end behavior is going to positive infinity in the y direction. That makes sense how I said that? All right, number 5, polynomial or not? No. Good. The reason it's no is I have a square root over a variable. So this is not. That's not going to be a polynomial. I can have a square root as part of it as long as the square root's above just a number. If it's above the variable, you're out. It doesn't work as a polynomial. What does the graph look like? I'm not worried about it right now because I'm only dealing with polynomial graphs. Can I move on?
Yes.
All right, use substitution to evaluate. Okay, now, do you want to see the long drawn out way where you can't figure out the numbers? Because the one way to do this, the long drawn out way, is you take this, you plug it in here, and you plug it in here, and you solve it. Okay, that seems pretty easy. But you want me to show you something called, it's synthetic?
Yes.
Synthetic's kind of cool, huh? That's a cool word. You're like, dude, yeah, I've heard that one. All right, ready? I'm going to put -3 right here. Is that -3 right there? Is everyone okay so far?
Yeah.
I made like this upside down looking thing. Still with me?
Like an L.
It does. Good. It is an L. All right. I'm then going to put my lead coefficients. I have a 5. I'm going to put right there.
2.
Okay. It goes to 2, so that's a -2. And then I'm missing the x value. Does everyone agree there's not an x to the first power up there?
Yeah.
So I'm missing x to the first, so I have to put a 0 for that place. And then I put 9 as my last term. Everybody see where those numbers come from?
Yeah.
Is this okay? Anyone scared? Because I'm not. Okay, ready? This is going to be the most mathematical thing you've ever seen. This comes straight down. Okay, there you go. What part of math is that? Well, it comes straight down. What kind of math? Comes straight down. Okay, what kind of... just come straight down. Just trust me. Ready? I think we can all do this. What is 5 times -3?
-15.
Does everyone feel comfortable saying that?
Okay.
Yeah.
I'm going to combine those together, so what do I get?
-17.
Good.
Wow.
-17. Ready? What is negative times negative?
Positive.
What is 17 times 3? Help me out.
I'm gonna do it.
It's 51.
51?
It's 51.
All right. Combine 0 and 51. What do I get?
51.
All right. 50 or positive times negative is negative. What is 51 times 3?
153.
153.
If I combine these together, what do I get?
160.
No. 144.
That's my answer.
Wow.
Wait, whoa. That's a lot.
What?
Okay. I could have done it this way. I could have went this way.
Can't we just like put it in and do it?
Yeah, you could.
That makes total sense, Drew.
All right, so I could have done it this way. And so that gives me 5 times -27 plus minus 9 minus 8, 18 plus 9. And then 5 times -27, whatever that is. Whatever this comes out to is the same answer. Do what?
Oh, yeah.
Okay? It comes out the same answer. Now, some of you might be looking at that going, dude, it's totally easier for me to plug it in. I agree. I totally agree. But the synthetic, this is actually called, I'm going to use a bad word. This is synthetic division. That's what it's called, is synthetic division. And that's our remainder because we don't like to divide in math. Okay? The only thing worse than division in math are fractions.
Or decimals. Decimals.
Fractions that are exponents, dude, those are the devil. Okay. All right. All right, so synthetic substitution, same thing. 3 comes right here. I have to put in a 0 if I have any gaps. Do I have a gap at x to the third? Do I have a gap at x to the third? Is there an x to the third up here?
No.
No, so I got to put a 0 in. And then I get negative 8, positive 5, negative 7. Okay? So, biggest mathematical term is? Bring it down. Okay? Ready? 2 times 3, 6. Still with me? 0 added 6, 6. 6 times 3, 18. Combine.
10.
10 times 3. 35 times 3.
105.
105?
Confused. Why? I get it.
90.
Good for you.
98.
98.
What's my answer?
98.
Done.
Nice job.
I like this way a lot.
I have no
I
idea.
feel kind of like a
It's
child
a
doing it, but I
synthesis
prefer
method,
it.
but
Oh, wait, no, this is easy.
Yeah, Cooper, you act like you know everything, then you skip the test every single time.
this I get.
LMAO.
He might have not felt well. I mean, heck, one kid puked. Oh, wait, that was you.
I didn't want to puke in front of everyone or on people.
Dude,
I
it was
didn't-
pretty funny.
It was pretty good that you
Thank
weren't
you,
here because
Cooper.
this projectile came this way. I mean, it could
It
have
was
reached you.
so bad. It was
I would have walked out. I'm letting you know.
So
All right.
I got crying.
So, you got that? Good.
So,
All right.
That would have smashed.
Synthetic division one more time. What am I going to put on the outside?
-3.
Yay! What's my first number?
4.
No.
0, 1. -1.
Next.
1.
Next.
-1.
No. 0. Why is it 0?
One.
Because there's no.
All right. Cool.
Drew, please.
I'm confused. Why
Where?
is the next layer?
Stopping. Where? What?
Why is it -1?
Because it's not there, so I have to have a 0 as a placeholder.
Okay.
Okay? Ready? Most mathematical term?
Negative
Can't you
1.
skip all that and go to the next -1? Because it's 0.
Oh, I don't know. I can't see it that well. All right. Negative times negative is positive. That's 3. That gives me 4. You with me?
Yeah.
4 multiplied -3 is -12. Combine those, I get -12. Yes?
Yes, negative.
-12 times -3 is?
Negative 3.
36.
36 is
That gives me a 35. 35 times -3, -105. Combine these.
What?
-104. What's my answer?
Where did we get -1?
-104. Did you get it? Thanks so much.
Thank you.
Yep. Any part of that's tough?
No.
So,
like that. Like the 105.
so all I'm doing, it's this times this goes here. Combine this times this goes here. Combine this times this goes here. Combine this times this goes here. Combine. Answer. All right. So, guys and girls, this polynomial actually would look like this if graphed.
I don't like those.
Okay. Looks like that one graphed. And at -3, so if on my grid I counted to -3, at -104, that's where that point exists. So that's something to think about. All right? All right. Shh. End behavior, we just talked about this. Okay? End behavior. All this is saying, if I have AX raised to some number, yes, I'm using hashtag, but that stands for the number sign. Okay? If A is positive,
Then hashtag.
it's doing that at the right side. Okay? Is that all right?
Yeah.
If A is negative,
It's doing that.
then on the right side it's doing that. So that talks about your end behavior. Your end behavior on the right side should be the easiest to figure out.
Yes.
Okay? So that's really what we're doing with end behavior. End behavior talks about what is going on with the range. The range is the y values. All right. Orange line. What's the end behavior to the right? right. As x goes to positive infinity, as x goes to positive infinity, as x goes this way on the orange, where does y go on the orange line?
Down. Up.
Which is what?
Axis. Sine. Range.
As x goes to positive infinity, so as your domain goes to the right, then your range on that orange line goes to positive infinity. What's the end behavior on the orange line over here?
As your x goes to positive infinity.
As x goes to negative infinity, because if I go this way to negative infinity, where's my range go?
Up.
So where's this going?
No.
So that's going to negative infinity. Black line.
Oh.
Black line, where's this going?
Down.
My end behavior on this is negative infinity. What's my end behavior up here? Positive infinity. So you're talking about what's doing in the y direction as the end behavior. Can I move on?
Yes.
End behavior on this red one. Both sides, negative infinity, yes?
Yes.
Blue one.
And then give it to me.
Positive infinity for my end behavior. Yes?
Yep.
Okay, too many people talking. All right. So let's talk about this. This is a line. It has a y-intercept of -7, has a slope of up 3, right 1. If it has a positive slope, that means it's increasing. You still with me? You have a positive slope, means it's increasing. My slope is +3, so it is an increasing function. So this is an increasing function. As I go to the right, it goes to positive infinity. As it goes to the left, it goes to negative infinity. Okay? So that's just a linear equation. This one here, that is a linear equation. It has a y-intercept of +7. It has a slope of -5. Being it has a slope of -5, that means it's a decreasing function. So as I go to the right in the domain, in the x direction, I go to negative infinity in the range, because my graph looks like this. Okay? And then the other one, as I go to negative infinity, my range, as I go left, goes to positive infinity. Those talking about the end behavior of our lines. Okay? Ooh, turn around.
I'm turned.
Brand new.
The other way, Cooper.
All the way forward there, Skippy.
Oh
All
my.
right. So this is a parabola. Does this parabola open up or down? Up. So what's the end behavior on both? Positive infinity on both. Okay? Is this also a parabola?
Yes.
No.
It's a little fatter. Does it still open up?
Yes.
So what's my end behavior?
Positive.
Positive infinity both ways. Okay? All right, this is called a third degree polynomial. So this graph, this is actually y equals x to the third. It might have some other stuff in it, but that's for the most part what it is. So where is this line going? It's going this way to positive infinity in the x. Where is it going in the y direction? Positive infinity. Agree? As I go this way to negative infinity, where is my graph going this way?
Negative infinity.
Okay, end behaviors. Does that make sense?
Yep.
You're talking about the range. All right. So, just for purpose, looks like this. This one looks like this. Okay?
Yep.
End behavior here. It goes to, as x goes to infinity, the end behavior goes to infinity. As x goes to negative infinity, your y value goes to negative infinity. Okay? On this one, it flip-flops. As x goes to infinity, y goes to negative infinity. On this one, as x goes to negative infinity, where does y go?
He looks kind of sexy.
Thanks.
I'm sorry if I'm interrupting some of you, and some of you are being extremely rude. Okay, and some of you might have to go see a dean here if your behavior continues. I'm serious. Okay, this is brand new material. You got people that are complaining about tests because they're too hard, and you're sitting there coming in my class talking nonstop. Figure it out. You're being extremely rude. This looks like this. So what's the ends doing? Positive infinity. This looks like this.
Negative.
Good. This looks like this. So it's going to have the same answers as that. This looks like this. So it's the same as that. This is to the sixth.
Positive.
This does this.
Negative.
Thank you. Yeah, buddy. Okay? When some of you are going, hey, this looks pretty simple. It is, but don't let it get in front of you, okay?
What?
Don't let it get too confusing. How do you decide the end behavior? We've already talked about both of those. Good. Oh. If it's in factored form. Ready? X times, how many x's would this be right here? X squared. How many x's right here? X third. So x squared is x to the third. X to the third times x to the third is x to the sixth. So this is a sixth degree. Ready? X to the third, x squared. That's x to the fifth. X to the seventh. Okay? If I were to multiply it out, but there's no reason to multiply it all out. Don't get there.
You're done.
Hey, worksheet 6B. If you are making up those two problems, it's due tomorrow. If you don't know what those are about, come see me. Have a great day. Take care of one another.